For the following problems, we are going to expand and condense the logarithms. In the first problem, we are going to expand the natural log of the quantity of 3x squared divided by y. When you work with expanding a logarithm, no matter what log base, natural log, which means log base 10, or log base 3, or log base 100, it doesn't matter. The rule always is, if you have a fraction or division inside of the log, then that can be separated into two logs of the same base with subtraction, which means this fraction is going to break up into the natural log of the quantity of 3x squared minus the natural log of y. We take the entire top and put it in the first log, and we take the entire bottom and put it into the second log and subtract them. From there, it's also true that if you have multiplication inside of your log, that can be broken apart into the addition of two separate logs. So this becomes the natural log of 3 plus the natural log of x squared minus the natural log of y. So we broke apart the 3 and the x squared. So from here, the last step is exponents. If you have an exponent inside of your logarithm, so it cannot be something like this, where the exponent is on the outside of the log. In this case, that exponent is attached to the x, and it is all inside of the natural log. So it could technically be written like this, but we don't have to use the parentheses. So when you have an exponent inside of your logarithm, you can take it and multiply it to the outside of the logarithm, which means this entire problem becomes the natural log of 3 plus 2 natural log x minus the natural log of y. And that is the completely expanded form of the natural log of 3x squared over y. Now we want to condense these logarithms. When you condense logarithms, all the rules that we just did apply, except backwards. Subtraction becomes division, addition becomes multiplication, and constants multiplied out front can be raised as exponents. The only trick is they all have to have the same log base to combine together. So notice all of these are just log, which means there is technically an invisible base 10. So they all share the same base 10, they can be condensed. We will start with the exponents, just like order of operations, exponents first. We want to take the numbers on the outside and move them up to the exponents inside of each log, which gives us log x cubed. Remember that cube is with the x inside of the log. If you need to remember it, if it's hard for you to memorize that, put parentheses around whatever is inside of the log. Okay, and from here we have minus the 2 is going to become the exponent of the y, so we have log y squared, and then plus log of x minus 3. Now we take care of this just like order of operations. Because we have subtraction and addition happening at the same time, we go left to right. To condense log of x cubed minus log of y squared, because we're subtracting them, it'll become log of the quantity of x cubed in the top and y squared in the bottom. So notice the subtraction became division inside of the same log base. And this is plus log of x minus 3. Now, because we are adding these two logs together, we will multiply the insides. So you could go through and multiply x cubed over y squared times x minus 3 and create common fractions that can be multiplied straight across. But just always remember, if you are adding the logs together, this value will go in the numerator. If you are subtracting them, it would go in the denominator. So this is just going to become the log of x cubed times x minus 3 all over y squared. Notice we just took the value x minus 3 and multiplied it in the numerator immediately. It's just a little shortcut we can use. And now from here we just want to simplify this with one more step by distributing this x cubed, which gives us log of x to the fourth minus 3x cubed all over y squared. And that is the completely condensed form of 3 log x minus 2 log y plus log of x minus 3.